everyone. This video is on oxidation and reduction reactions. These are very unique and we don't do a whole lot with them for the rest of the semester, but they are important and we do want to at least introduce you all to these. And the reason that they're different is because electrons are being lost and gained in these reactions. And so we actually have electrons in our equations that we're going to look at. Oxidation is the loss of electrons from an atom. So I think of this as lose electrons oxidations. So I think of this as LEO, helps me remember. Lose electrons oxidation, and if an element gains electrons, it's going to be reduced. So this is called LEO and GER. That's how I remember it. Lose electrons oxidation, gain electrons reductions. In a oxidation reduction reaction, both processes have to occur. You have to have an oxidation and a reduction, and it's called a redox reaction. So one element has to be oxidized and one has to be reduced in order for these to work. So these involve the transfer of electrons from one element to another. They're called redox, and we're going to look at them in detail here. So if you look at this experiment, you've got zinc strip and a copper solution. So zinc solid has a 0, it's neutral. But then when it is put into this solution, it becomes zinc 2+. So if it has a positive charge, that means it lost electrons, right? Because electrons are negatively charged. So if it becomes +2, it lost 2 electrons. So lose electrons oxidized. So the zinc is oxidized and the copper has to be reduced in order for these to work. So if you look at copper, it was 2+, and then it became copper with a neutral charge. So it gained 2 electrons. It went from being negative to neutral. So 2 minus 2 equals 0. So it gained 2 electrons, and so the copper is reduced. Gain electrons reduced. You can look at these as half reactions, and all that means is you find the reactant on the left that looks almost exactly like the product on the right, and you just pull those apart. So you pull it here, and it's called a half reaction. And if you look here, in order for this to be balanced, you have zinc becomes zinc 2+. So that means it has to have lost 2 electrons. Okay, so for redox reactions, you balance them just like you would your typical chemical reaction. So you have one zinc and one zinc, but these have charge, and so you have to balance the charge. So here that's considered 0 because there's nothing there. So here this side is 0, it's neutral. But then it went to 2+. So we need it to be equal to 0. So 2 plus minus 2, okay, -2 for 2 electrons equals 0. Okay, so now you have mass balance, meaning you have one zinc on each side, and you have charge balance. So this was neutral, and we have 2 minus 2 equals 0. And so because electrons are on the product side, that means that zinc lost electrons, which we already established that, and so it's the oxidation part. For copper, it is the reduction component, and it had to gain 2 electrons. So it had to gain 2 in order to produce copper neutral. Okay, and so if you look here, we have 1 copper on each side, and then here we have 2 minus 2 equals 0, and then this copper is neutral. So we call this mass and charge balanced. Okay, and just breaking each of these down into half reactions. Right. This gets a little confusing, so I'm going to try to explain it the best I can. But a compound, so we established that zinc was oxidized because it lost electrons, and copper was reduced because it gained electrons. Okay, and we see this here. Okay, zinc lost electrons to the product side, copper gained electrons to the reactant side. Okay, so think of our reactant, so the electrons are on the reactant side. Okay, a compound that is oxidized, it causes the other compound to be reduced. So it's called a reducing agent. So this is confusing here. So zinc is oxidized, but it is the reducing agent. Okay, so opposite of what you might think. Okay, copper is reduced. It's the reduction part, but we call it the oxidizing agent because it causes zinc to lose electrons and be oxidized. Okay, and so it's sort of the opposite. So you look at it at first, decide if it's oxidized or reduced, and then that means it's the opposite agent, if that makes sense. So if it's reduced, then that means it is the oxidizing agent. And we know that copper is reduced, remember, because it had to gain electrons. It had a positive charge, and now it's neutral. So it had to gain negative charge. Okay, so here's some more that we can look at. So if it's an oxidation reaction, the electrons are going to be lost. So lose electrons, oxidation. So look here. All of the electrons are on the product side. Okay, reduction reactions, electrons are gained. They're on the reactant side. Electrons have to be gained. Chlorine has to gain 2 electrons before it can produce the 2 chloride ions. Okay, so here's some more examples for practice. The oxidation of iron, this is iron rusting. So here's iron atoms, and then here's the red, here are the oxygen ions. Okay, iron and oxygen both are neutral. Okay, and then if you break this down, we learned how to name and write formulas and see what our charges are. But if you look at it backwards, this charge goes here and this here. So we have a 3+ charge on our iron, and we have a 2- on our, so this is iron 3 oxide, the name of this. Okay, so if you look at it, iron goes from being neutral to having a +3 charge. So that means that iron is, so if it goes from, it lost electrons, right, neutral, so 0 to 3+, okay, it lost 3 electrons, so it is the oxidation. So iron is oxidized. Okay, oxygen gained, it went from neutral to negative, so gain electrons, reduction. So oxygen is reduced. Okay, so iron is oxidized and the oxygen is reduced because it is gaining 2 electrons. And if we wanted to speak of these as agents, we would call the iron the reducing agent, and we would call the oxygen the oxidizing agent. Okay, so that just shows that iron loses electrons, so it's oxidized. Oxygen gains. Leo and Ger lose electrons, oxidized. Gain electrons, reduced. the components of a battery. We have oxidation reduction reaction going on. Okay, zinc becomes zinc 2 plus, and our manganese becomes manganese 3 plus. Okay, and so maybe the best way to see that is here. So we go from being neutral to 2 plus, so lose electrons, oxidation. Manganese goes from +4 to +3. Okay, and so +4 to +3 means it had to gain electrons. Okay, so those are on the reactant side. Here electrons are on the product side for an oxidation. And so we have a Leo and Ger redox reaction. Another example is this is how a pacemaker works. So lithium is oxidized, electrons are lost on the product side, lose electrons, oxidation, and iodine, it gains electrons. Okay, and so that's what's going on involved in a pacemaker. They have an oxidation redox reaction. Lithium is oxidized and the iodine is reduced. All right, I hope this helps, and I'll see you next time.